So the names now should match the workshop. So this one definitely does. Okay. So we should be live now. Excellent stuff. And we're going to make use of a couple of diagrams here. Just my disclaimer, these are not my diagrams. So these come from a guy called Tony Alicia. I think that's how you pronounce his name. So he's the guy who did the course Understanding the Weird Parts of JavaScript. So it's a very, very clear explanation of some of the stranger parts that are harder to grasp in JavaScript. So that's his website there. As we're using this stuff, I thought it only fair that we just let you know about that. So learnwebdev.net, and you can find all the details on there. Anyway, back to our stuff. So let's talk about passing arguments into functions by value, by reference. What is it? Does it depend on the data type? All that sort of stuff. So let's go back to some basics and let's just look at the data types, some of the data types that we have in JavaScript. So for example here, what is the data type of the variable a? It's a number, right? Cool. Do we class number as a primitive or a non-primitive data type in JavaScript?
What's the difference?
What was that, Bouquet? Yeah, primitive, definitely. But what did you say, Bouquet? Something different?
What's the difference?
What's the difference? Yeah, okay. We'll come to that, definitely. So there are... I've got my numbers right now. We'll have to go through them. So what are all the different primitive data types in JavaScript? We said number. What else have we got? String is primitive, yeah. Booleans are primitive, so true and false, yeah. Is an array primitive? Not primitive? No. Anything else? Symbol, yeah. Symbol is one. That was a new one introduced in 2015. That's a primitive. Say again? Null is, and undefined is as well. I think that's the lot. So that makes 6, doesn't it, including symbol? And as we go through this workshop, hopefully we'll begin to see some differences. So I won't address the differences now. But yeah, just know that those are our primitives. And everything else is effectively an object in JavaScript, and that's a non-primitive. So even an array is a type of object. So yep, we would class that as a non-primitive. So we're just going to look at some assignment here first, and then we'll look at actually passing values as arguments into functions. Yeah. So this assignment we got here, we're just assigning a equal to 1. Then we assign b equal to a. So what's the value of b going to be at that point in time?
1.
Cool. Agreed. And we're then going to change a to 3. So if we console log a, what will be the value of a? 3. Everyone shout it out. Good. Yeah. And if we console.log b, what will be the value of b? 1. Agreed. Yeah? No, nothing surprising there, right? How about if we look at a non-primitive data type? I didn't actually mean to do that. It's easier to work with objects, I think. And we initialize a to an object containing a key num and a value of 1 of that key. Yeah. Then we still assign b equal to our object. So what's the value of b going to be? It's the same object, right? Num and 1 in it. Cool. Then if we reassign the number property, so we're not necessarily reassigning, we're modifying the value of the number property to 3 in a. What is the value of a going to be first? So we've done a.num equals 3, so that would hopefully change this value, yeah? Change the number 1. So object a now is just going to be what? Number 3. Yeah, an object with number 3 inside. Cool. And if we console.log b, what's b going to be? We haven't changed it anywhere, right?
Number 1.
So b...
I mean object number 1.
object number 1. We would think, right? We haven't explicitly changed B anywhere. So if we run that, what do we get? We actually get num3. So we've changed the number property on A, yet when we log B, we also seem to have changed B. How did that happen? That didn't happen with numbers, but it happened with objects. What's the difference?
So for the primitives, what's the substitution for the non-primitive? They inherit.
Let's look at one more change first.
They access the same place in the memory.
So, yeah, it's definitely something to do with memory and where they're stored in memory. So Bouquet said they access the same place in memory. If I literally just have them equal to the same thing like that, so they both contain the same values as before. We haven't directly pointed B at A, but we've just given them the same values. I now change the number value on A. What's B going to be this time? Is it still going to be num3 or is it going to be num1? Num1. So it's num1 this time, because when we've created our variable B here, we've pointed it to this value and it's created a whole new place in memory for that. We'll look at the diagrams in a second, but this is just the code to explain it. So these two have different places in memory when we've declared them in this way. If we declare B equal to A, what we've actually done is we've pointed B to the same place in memory, the same memory address, or the same reference, if you like, if you want to use the word reference, so that when we change one of them, we also change the other one. Likewise, we could have changed b.num equals 3 and console.log A, and we will still have num3 for A. Yeah, it doesn't matter which way around we change it.
This property is the same thing maybe then after when we can't change const, like assign to const an object, we can add something.
Yeah, we'd try and maybe look how it
So it
ties in with variable declaration as well. Yeah, slightly different. Let's keep it on this track for now, and then at the end we might be able to include that little bit as well. But just to visually explain or visually represent what I've just said with words and with that little bit of code, this is what's happening when we're dealing with primitives, yeah? So on this line of code, B equals A, what happened? Well, we already had A stored, right? It's been given this memory address, just in hexadecimal for whatever reason, yeah? So we've got a memory address here and a value. And A itself is pointing to the value, yeah? So the value of A is actually, in our case, 1. It was, right? We used the number 1. And then when we do B equals A, we create a separate memory address with a copy of the value of A. And the value of A was 1 in our example. Yes, we've got two distinct places in memory with a copy of the value. However, when we looked at non-primitive types, so something like an object, we have this scenario. This is essentially what's happening. So, we initialized A to have a value of an object with num1 inside it, the key value pair. That was given a memory address, and essentially A is pointing more, the value of A is more the memory address in this case, and it's pointing, that memory address points to the object. When we do B equals A, this is the part we copy on the complex data type. We copy the reference, we copy the memory address. So if you like, we're passing the address for complex data types rather than passing the actual value of the object. Does that sort of make sense with those diagrams? Yeah, I think they're pretty good diagrams. You can clearly see the difference. And of course, when we actually declared a new instance of an object, then we created a totally separate space in memory. But when we did this b equals a, this is the kind of scenario that we're doing. All right.
What does it mean, or pass to a function?
Yep, so that's what we're going to look at next, because that's more what the workshop's about, when we're passing to functions rather than just writing code like this. Usually we'll be working with functions, right? So if we start with the numbers example again, so I've got a and b here. Whatever, we can call our arguments anything we want, right? Is there any way to mutate these numbers? In other words, do we have any mutator? Or maybe I should use strings. Strings is easier, perhaps. So, and then if we make b a copy of a, and we try and change it in some way, is there any way we can mutate this original string a?
Object of
What's that?
I was going to say object of product, but you cannot do that.
But, you know, let's use some string methods, you know, things like slice. Can access the index. So you want to try and change it by accessing the index, yeah?
If you want to change it, if you say A0 is equal to B, then it's going to be bigger.
Yep. So we want to change hello into what? Huh? Yellow? Yeah?
Whichever you choose.
So we did something like that?
Data type 10, yes.
Yeah? So you think that will change H into a Y?
Yeah, it should be yellow.
Okay.
But hopefully.
And then return data type 1, right? Okay. Anything wrong with that? Shall I run it? See what happens? Still hello. Yeah?
Strings are immutable.
Strings are immutable. Yes, 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 yes. Strings are immutable. We can't change strings in JavaScript. Yeah? So in other words, all of the built-in methods, none of them will be mutator methods for strings. With arrays, that's different. So if we had an array of hello, and we then change the first element in the array to yellow, then I think now this will work. Oh, no, I didn't put A as well. Oh, I haven't wrapped my function, have I? Schoolboy error. Okay. Yellow, yeah. So we've managed to change the properties of that array there.
Can you access H when it's inside an array? Can you still try to change it with an index? Aiming
Counts.
for H like 0, 0.
Can we access H? What, by doing something like
0, 0.
that?
Exactly. Does it become mutable then?
Are we mutating it? You said, can we access it? Is accessing the same as mutating? Oh, but you want me to change it, didn't you? So
Exactly. So if you assign y to that statement, data type for line 2, if you assign y,
but we're still trying to modify a string, right?
so it won't allow you.
So you want to do something like that again?
Yeah.
because it's a string that you're trying to modify. Yeah. But how can we actually modify arrays? Apart from obviously the way we did, but we've got various methods, right? We've also got push methods, pop, all stuff like that that we say don't use if you want to keep your functions pure, but they do exist. So we want to demonstrate what we previously had over here, but by using a function instead. Yeah. So when we pass in, who wants to have their name? Should I say hello to you, Bouquet? So if we push Bouquet to our first array, will that change our second array?
Should update. No, because there's a reference in the memory. The question is, on mutation, we need to create another one. That's object-oriented.
Yeah, so is it creating a copy of data type 1, and is it passing the value by the, is it pass to the argument here, right? So this, is it passing it by value or by reference up here in our function arguments is the question. Yeah. If it passes it by value, we would expect them to have two distinct places in memory, right? And when we push to one, it shouldn't change the other. If it passes by reference, we should expect changing one also changes the other, because they both have the same physical location in memory, and it's the memory that we're mutating. Yeah. Not sure? Do you want me just to call these A and B as well? Will that help rather than having? Yeah. Okay, so we push something to A, we're returning B. Will it have one element or two? Two. It will. Yeah. So when we pass in our values to our function, if they're complex, they're passed, or if they're non-primitive, they're passed by reference. It's the same thing, right? Yep. So how can we get around this?
You can create new.
So I want to leave a.push Bouquet and return B, and I want B to just have hello in it. That's all I want. A.push, but I want A to still have hello and Bouquet in it as well. Return B.pop. Okay, but I also want to return B just as it is.
Do you have a statement to say fix B, don't change it?
Fix B, no, I don't think that exists in the core JavaScript language.
We have to return B.
Yep, we have to return B.
Can you say B equal B, or it doesn't make sense?
Yeah, so I think we've got to do something with reassignment, yeah, because when we looked in the first example, when we did something like that, they actually had separate spaces in memory, yeah? So can we use reassignment to get around that problem? So we could either do, I think what Nico suggested is this, B equals B, just that, right?
Yeah, just I'm not sure, but it's an idea.
Yeah. So that's one idea. Would that work?
Make B immutable.
Make B immutable. Again, I don't think make immutable is a core JavaScript function, unfortunately. They either are or they aren't, depending on their value, their data type. Okay, let's see what happens. Let's see what happens. So that hasn't helped because essentially all we've done is point B to the same memory address that it was already pointing at, right?
What if you use a free blocks?
Yeah, I like that even better. What if we essentially create a copy of the spread values of B and stick that in a new array? Will that give it a different memory address?
So this will stop the connection between.
So this will stop the connection. This will stop them both pointing at the same object in memory, yeah. Nice. Yeah, so we've reassigned it to something new essentially. Yeah, we've created a new instance of array that takes a new space in memory. It might have the same values initially. Yeah, because if we didn't push anything to A, then so B is hello like that. So on the surface, they look identical, right? An array hello, an array hello. They contain the same element with the same value, yeah? But in memory this time, because of using this reassignment with destructuring, they're pointing to a different space in memory. Yeah? So they're not sharing their reference value. So that's one way we could get around.
I think it's a new solution because the rest of it is quite.
It's a new solution, but it's quite an elegant one, yeah.
An old school method to make the same thing.
Mm-hmm.
So if we don't have the spread operator, how can we?
An old school method. We used to use things like object.assign, I think, but again, there's a big topic again on that. Like how do we copy arrays? How do we copy objects? How do we deep copy them, shallow copy them? And it's a bit probably beyond the scope of just this introduction to it. But
Objects, so we stop the affected by the.
yeah, essentially, if you're using mutator methods like push and pop, and you don't want any unexpected side effects later on in your code, when you then try to call B later on in your code and you're expecting it just to have one value but it's got two, then make sure you create a copy of it, and that's a nice easy way to do it using the spread operator before doing any operations. So you break that link to the other object. I mean, you might want them linked, but in this case we don't. Yeah. Cool. So the only other thing I wanted to tie it in with was we often do comparisons, right? Are value 1 and value 2 equal? And we've got to be careful when we're comparing primitives to when we're comparing non-primitives or more complex data types, right? So if they both had the value of 7 and we return value 1 equals value 2, is that going to give us true or false?
Primitives should give a true.
Okay, so when we're comparing primitives, using the triple equals should evaluate to true.
Because we have a location list.
But in this case, if you don't use triple equal,
So someone said that was false. All right, we'll do that first. Yeah. So yeah, because the data type is different. One's a string and one's a value. Yeah, so that's definitely false. Good. String and string. No matter what the string is. Blah, 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 yeah. Obviously, it's got to be the same. And that's true. So our string is a primitive. We can compare it using the triple equals. How about...
If you put an object.
Yeah, I was going to do an array first, because we had a bit of a question over the array, I think, initially. So I've got an array of a couple of elements. I'm beginning to create an array of a couple of elements at least.
Like, is an array a primitive? Or, oh, it's not.
So that's the question we need to ask ourselves. Yeah, again, is an array a primitive, or can we use triple equals to compare two arrays? Why does it matter if the location in memory is different? I just want to say, are these values the same as this, right? So it's returning false, but why is it returning false? What is it comparing that isn't the same?
Object ID memory address.
They look the same to me.
Exactly. So the values inside look the same, but what is this doing? Well, it's comparing the what am I trying to say? It's comparing where it's stored in memory. Yeah. So essentially, the value here is a reference address, a memory address, and it's trying to compare those two, and they are different because of how we have initialized it down here. We've initialized them as separate. If we initialize them to like that, so they share a memory address as well as share values, what will it be now?
No.
Now it's true, because they're pointing to the same location in memory based on that diagram, yeah? Oops. So, yeah, we have got to be careful when using the triple equals and doing comparisons. This triple equals will only work for primitives. Yeah, if we have an object as well, as Vilius suggested, well, that was complex. So if we go back to our original example, we had num1 on the surface, looks the same, right? Excuse the spacing, but if we do the comparison, they are false. Yeah. Okay, questions?
Okay, so JavaScript kind of compares memory address. Checks objects like address
For
or
non-primitives.
object ID.
Yeah, for non-primitives. Yeah, it's comparing the object address. But it can't be comparing the object address for primitives, right? Because those have different memory addresses as well. Yeah, but yet when we run that, it's true. So the primitives, it's comparing the actual visible value that we see on screen, whereas with the non-primitives, it's comparing the memory address and the values, technically.
If you remove one of the equals and make it a truthy falsy comparison,
That one?
would it still be true?
And make it a truthy-falsy comparison. What do you mean? What are value 1 and value 2 going to be?
At this point, it should still be true.
At this point, it's definitely still true, yeah, because the value's the same, the type's the same, everything's the same. Memory address is different, but it doesn't matter for primitives, yeah?
And for non-primitives, even the strictly equal didn't work.
And for non-primitives, even the strictly equal didn't work, so the double equal isn't going to work either.
So if in a problem we actually want to compare two arrays, at some stage we are playing with some two arrays, and
Yep.
we want to, okay, now if they are equal, do this, if not, do that.
Yep.
So what is a viable way?
What's a viable way of doing that? If you're concerned about the order as well, you might iterate over them and compare them at each stage.
Compare each element.
Yeah, to its...
It's just very counterintuitive.
Yeah,
I mean,
I agree. Yeah, there's not a built-in method to compare non-primitives. No. Yeah, essentially. Yeah, yeah. There might be in the future a language. Hopefully, there will be. Certainly in popular utility libraries like _, then I think there exists an is equal or something like that function, or is complex equal, you know, something like that. I don't use them, so I don't know exactly what it's called, but there's a method in there that will compare objects and arrays, and you can look at the source code in that, so you can see how they do it as well. Yeah, but you know, if you're curious, it might be a good way to learn how they implement that function, and could you create a slightly simpler one of what they've done, but obviously yours only works for certain cases, whereas theirs has to cover a huge range of test cases, and all the little quirks of the language they have to make sure they cover in their method. Whereas if you're sure of what your data is going to look like, then you might be able to just write a simpler function that would help you do a comparison like that.
Thanks.
Yeah? Anything else, or shall we leave it there? But yeah, I posted a few links on Slack, so that's a bit of further reading around the subject. And I will try and make sure that obviously I get those links to you a bit earlier next time, and I'm in the process of creating a whole resource links page, and then everything can just go up there. And I know a few people in general have recommended this resource, that resource, so I'll make sure they all get incorporated in. Then eventually we'll have a function that you can submit your own resource links as well, so that you won't have to do it via me. They just go straight onto the page, onto the resource links page. Yeah, like a form, it just put it up there. Nice. Cool. We'll leave it there then. Yeah. Thank you very much.
Thank you.
Clap. I got a clap that time. It's the first clap I've got. Thanks for it.